Hello, welcome. Let's try to solve another Leetcode problem. 1016 binary string with substrings representing 1 to n. So for this problem, we are giving a binary string s and we are also giving an integer n. So we're gonna return true if the binary representation of all the integers in the range 1 to n are substrings of s, or false otherwise. So we should know what is a substring. Yeah, so let's just check the first example. So for the first example, n equal to 3, it means for 1, we have a substring, which is 1. For 2, we have a substring 1, 1, so this is 1, 1. And for, for 2, we have a substring 1, 0, so this is 1, 0. And for 3, we have 1, 1, so this is 1, 1. So this is why it is true. But for the second case, this n equal to 4, it means we need to have a substring 1, 0, 0, but there's no substrings of 1, 0, 0, so we're gonna return a false. How can we solve this problem? Yeah, if this n is a really small value, that is okay. For example, if n equal to 10 to the power of 4, we can directly solve it by using the brute force. Yeah, so let's just check the n. But n equal to 10 to the power of 9, this means we cannot solve it by using the brute force. Yeah, so instead of solving it straightforward, we're going to solve it reversely. So the reverse idea is just the sliding window idea. We just need to use the string s to enumerate all the cases, and then we're gonna check from 1 to n if those kind of numbers is inside the set or not. Yeah, we're gonna prepare all the cases inside the set, and then we're gonna check from 1 to n if all numbers inside the set, then it's gonna be true, otherwise it's gonna be false. Yeah. So now the problem gonna become an easy problem. So we're gonna check the length of the string. And then we're going to use a fixed sliding window. So for I in range L, for J in range I. So here, because the maximum number is 10 to the power of 9, but for binary representation, we just need to at most have 30 bits. So this means from range I to I plus 30, so that is enough. Yeah. And then we're going to put all the possible numbers inside a set. So here we're going to prepare a set. So here I'm going to use the set underscore because I have s, so to distinguish with it, I'm going to use the set underscore to represent a set. Yeah. And for this set, definitely there's not so many numbers. So maximum there's going to be like 1000 times 30 numbers. That is not big enough. That is why we can solve it directly. Yeah. So we're going to add such number. It's going to be an integer. It's going to be si to j plus 1. Yeah, so that's going to be all the possible cases, but it's going to be a binary number. So for the integer, we're going to use a binary number. So we're going to turn the binary number into a digital number, and then we're going to check it. Yeah. Now we're going to check all the possible cases from 1 to n plus 1. If I not inside the set, so we're gonna return a false, otherwise we're gonna return true. Now we can clearly see the time complexity, which is dependent on this n, and n is just like yeah, it is dependent on here. Actually it is not n, because for here this is just 1000 times 30. It is 10 to the power of 4. But for here, you might think this is a really big value. Why we can use this? Yeah, because actually it's gonna stop earlier. Maybe it's gonna stop not 10 to the power of 9. Maybe it's gonna stop at 10 to the power of 4. And definitely, not maybe, definitely it's gonna stop at 10 to the power of 4 because they're gonna be at most have 1000 times 30. 3 times 10 to the power of 4 numbers. That means it's gonna stop earlier. That is why we can use it. So the time complexity is gonna be 10 to the power of 4 or 30 times 1000. That is why we can use it. Yeah. So don't be mistaken by this one. It is not ON. It is not 10 to the power of 9. Actually, it is just 1000 times 30. Yeah, because the for loop gonna stop earlier by a false. Yeah. But if this n is a smaller, like 3, it's gonna finish all the checking and it's gonna return true. But if this n is too big, like 10 to the power of 9, 10 to the power of 5, it's gonna stop earlier. Yeah. or you can solve it directly for this n, but it is also okay. Yeah. So here I'm gonna use an easy way of sliding window to solve the problem. I hope you understand it. Now let me just run it. Yeah, as you can see, it passed for all testing cases and it's pretty fast. I think that's all about it. Thanks for watching. See you next time.